You guys, this looks like a fun one. We're given a quadrilateral that's a kite with sides 1.5 and 3, and there's a circle inscribed in it, and it wants to know what is the area of that circle. We're also given that this angle is a right angle. If you want to try it on your own, pause it right now, because I'm going to solve it in 3, 2, 1. First, one of the properties of a kite is these two angles are always congruent. So this is a right angle. Here are the notes right here. These two angles will always be congruent, and these two angles will not be congruent, but they will be bisected by the diagonal. I'm not sure if we need that second property, but it's a fun one. Next, let's do some stuff inside of the circle. From this tangent point, we can draw a perpendicular line that'll be the diameter of this circle. And same thing from this tangent point, we can draw this perpendicular line. It'll also be a diameter of the circle. Since each of these are a diameter, that makes this the center. So that means this is going to be equal to the radius. We'll call it r for radius. And this down here is also going to be equal to r. So let's bring this down here and let's label this r. And that means this piece is going to be the whole thing 3 minus this r, to give us 3 minus r. And we can do the same thing with this 3. We can bring the 3 out here and rotate these so that this is a right angle and this is a right angle. Now each of these are going to be equal to r, which makes this portion also equal to r. And then this remaining portion is going to be equal to the whole thing 3 minus r. Now what are we going to do from here? Let's rotate this over here till this is a right angle. And let's move the R over here. Now this is pretty cool. We have two different kites. We have the little guy here and the big kite here. For this bigger kite, let's clean up the inside. And then we could change this whole side back into 3. And we can do the same thing here. Now each of these kites contain two right angles. And this red angle is shared. It's the same as this angle up here. That means that this fourth yellow angle also must be congruent. Now, since all these angles match, these two kites are going to be similar. We can say this side r divided by this 3 minus r is equal to this 1.5 divided by this 3. And now we have an equation in terms of r. Let's see if we can solve the r. First, we can cross multiply. This will be 3 times r is equal to 1.5 times the quantity 3 minus r. On the left-hand side, we can copy down the 3r. And on the right-hand side, we can distribute this 1.5 to each of these terms. 1.5 times 3 is equal to 4.5. And then we could subtract 1.5 times r, which is 1.5r. And then from here, we can add 1.5r to both sides. On the left-hand side, we have 4.5r. And on the right-hand side, these are going to cancel each other out, leaving us with 4.5. Next, we can divide both sides by 4.5, and that'll give us r is equal to 1. And that's the value of the radius. So now we can find the area of the circle. The area of a circle is equal to pi r squared. So in the place of this r, we can plug in 1. 1 squared is equal to 1, so that means the area is equal to pi. And that is the answer to our question. In this given diagram, the area of this inscribed circle is equal to pi square units. Let's give it a label of square units and put a box around it. How exciting. And here's the next puzzle. It's another find the area of a circle, but this time it's inside of a regular pentagon. And each of the sides are 2 times the square root of the quantity 5 minus 2 root 5. This looks like it's going to be a fun one.